Hello, dear students. I am Dr. Girija Swami, Associate Professor of Chemistry, Maharani Science College for Women, Mysore. This is the first session of Hydroxy Acids, 6th semester Chemistry, DSc 2B, University of Mysore. In this session, I'll discuss about definition and classification of hydroxy acids, synthesis and importance of lactic acid. An organic acid containing both a carboxyl and a hydroxyl group and showing the properties of both an alcohol and an acid are called hydroxy acids. So these are the two examples, glycolic acid and lactic acid. Classification of hydroxy acids. They are classified into alpha hydroxy acids, beta hydroxy acids, gamma hydroxy acids, and polyhydroxy acids. Example for alpha hydroxy acid is lactic acid. Here OH group is present on alpha carbon atom. Example for beta hydroxy acid is beta hydroxy butyric acid. OH group is present on beta carbon atom. Example for gamma hydroxy acid is gamma hydroxy butyric acid because OH group is present on gamma carbon atom. Example for polyhydroxy acid is glucose. Physical properties of hydroxy acids. Hydroxy acids are colorless crystalline solids or syrupy liquids. Their melting and boiling points are much higher than those of the parent unsubstituted acids. They are soluble in water than either the parent carboxylic acid or the alcohol, since both the functional groups in them can form hydrogen bonds with water. They are stronger acids than the corresponding unsubstituted acids owing to the electron withdrawing effect of OH group. For example, hydroxyacetic acid is stronger acid than acetic acid. Chemical properties of hydroxy acids. Hydroxy acids give reactions of both the functional groups, an alcoholic and a carboxylic groups. The first hydroxy acid is lactic acid. IUPAC name of lactic acid is 2-hydroxypropanoic acid. Common name is alpha-hydroxypropionic acid. This is the structure of lactic acid. It contains one asymmetric carbon atom because this is the chiral carbon atom. It is attached to 4 different groups. Sources of lactic acids are: it is found primarily in sour milk products, yogurt, sourdough, bread, wine, and fermented soya foods like soya sauce. It is responsible for their tangy flavor. In addition to the fermented vegetables and grains, fermented dairy products like kefir contains lactic acid. Physical properties are: it's a colorless crystalline solid, melting point 53 degrees centigrade, and has sour taste. It is optically active because it contains one asymmetric carbon atom. Specific rotation is plus 3.82. Lactic acid obtained from molasses is D-isomer. The synthetic product is racemic lactic acid whose melting point is 18 degrees centigrade. It is soluble in water, alcohol, and ether. Chemical properties of lactic acid. It gives reactions of both secondary alcoholic and a carboxylic group. First is the reaction involving carboxylic group. In that, formation of salts. Lactic acid reacts with alkalis to form salts. Lactic acid reacts with sodium hydroxide to give sodium lactate. Second reaction is reaction involving OH group. Lactic acid reacts with acetyl chloride. The H of OH is replaced by acetyl group. Third reaction is reduction. When heated with hydrochloric acid, it is converted into propionic acid. Next is on oxidation with Fenton's reagent, it is converted into pyruvic acid. With KMnO4, it yields acetic acid. Reactions involving both OH and COOH groups. With PCl5, both OH and COH groups are attacked by phosphorus pentachloride to form lactyl chloride. This is the reaction. Next is the action of heat. When heated alone, it forms an intermolecular cyclic diester called a lactide. Here H and OH groups reacts, H2O is removed. Here also H2O is removed. We get lactide. Reaction with sulfuric acid. When heated with dilute sulfuric acid at 130 degrees centigrade, lactic acid is decomposed to yield acetaldehyde and form an acid. With concentrated sulfuric acid, formic acid is further decomposed to carbon monoxide and water. Synthesis of lactic acid. Lactic acid is synthesized by taking acetaldehyde and cyanohydrin, that is hydrogen cyanide. Hydrogen cyanide adds to carbonyl group. H is added to O, CN is added to carbon. We get cyanohydrin. This cyanohydrin of acetaldehyde on acid hydrolysis, we get lactic acid. Importance of lactic acid. Lactic acid bacteria are one of the most significant groups of probiotic organisms commonly used in fermented dairy products. Among other benefits, these microorganisms can enhance lactose digestion, stimulate the immune system, and prevent and treat diarrhea. These lactic acid bacteria has very important industrially and is used for milk preservation, fermentation, and cheese, yogurt, and buttermilk. The prominent role of lactic acid bacteria in agriculture. Lactic acid bacteria increases the solubility of fertilizer. It can directly promote the plant growth and seed germination, as well as elevating various abiotic stresses. These will neutralize ammonia gas produced where the immature compost is applied. Lactobacillus is a beneficial bacterium that helps sterilize soil and remove byproducts that can build up and create a harmful environment. The presence of lactobacillus limits the undesirable organisms in the soil. This creates a more balanced environment that is able to support plant life. MCQs are hydroxy acid shows the properties of, you have four options here, and the answer is alcohol and acid. Second question is lactic acid contains secondary alcoholic group. Lactic acid is an example for monocarboxylic acid. Number of asymmetric carbon atoms present in lactic acid is 1. Lactic acid is soluble in all the above. Thank you.